Ladies and gentlemen, thank you very much for coming. So, journey of feature flag development in Line Android. So this is the title of my presentation, and I would like to introduce the development and management method. Let me introduce myself. I am Tamaki Hidetsugu. I joined Line April of 2018 after finish the school, and I'm responsible for Line Android development. So, as a development and management, we have used the feature flag instead of the feature branch, which is more commonly used. In this session, why we decided to use the feature flag, and also what is the problem using a feature branch, and also with the feature flag, what kind of benefit we can enjoy, and also the how we improve the environment for us to use the feature flag. I would like to cover these points. So first, let me talk about the development using feature branches. So feature branch development is very well known, very popular. I think many of you are already using it. So even though you don't know the feature branch, but you might have used the Git flow or GitHub flow, and they are actually the method to use the feature branch. So this is a very well-known development method, but why we don't use it? So I would like to introduce what are the pain points of the using feature branch. So this is the basic concept of feature branch. So the development with a feature branch. So there are things, the main branches are called master or trunk or development. And from a main branch to develop some feature, you generate the branch, and that is called as a feature branch. And to develop a feature, you need a pull request, and each pull request is merged into the feature branch. And once the feature is completed, entire feature branch is merged into a main branch. So it looks there is no problem using this method, but using the feature branch, and we did development, but we faced a lot of issues throughout development. So the Line Android development team consists of almost 100 developers, and we do parallel development. So the changes to the repository is about 20,000 lines per week. So our environment is huge, and if we use the feature branch, it looks like this. So in a huge, gigantic app development, as you can see here, there are multiple feature branches at the same time, and they are interrelated. So even though the new feature development or refactoring, also the number of the files to be written would be many. So there are more conflict. So the situation is more prone to conflict, and we have to spend more time to solve those conflicts. So our team decided not to use the feature branch. Instead, we decided to use feature flag. So with the feature flag development, what kind of benefit we can enjoy, I would like to touch upon that. Development with a feature flag Each new feature pull request is merged into a main branch, even though the feature itself is still under development. So the development with feature branch. So the pull request merged into the feature branch is actually merged into the main branch in case of the feature flag. However, with this, the incomplete feature or the feature which are going to be released in a later version could be executed on a binary which are already distributed to the store. So we prepare the Boolean type flag, and with that flag value, we can specify whether this feature should be on or off. So when actually the feature is going to be released, this flag is written to true, then we can make this feature valid. So the value of this flag, I would like to show you two examples. The first, whether the view is visible or not to use the feature. So for example, the new feature, the sticker feature, for that new feature, you have the feature flag called feature sticker. So if that flag is on valid, the stamp palette is displayed. So the button for that function is displayed. And in case of the Android, there is an activity which is the screen of the transition destination, and feature flag value can be used to switch that feature. So if there is a new screen, and if the feature flag is on, the newly created screen is displayed. So with this, the existing screen code can be kept as they are, and we can proceed the switching over action. So it is also possible to switch over the presentation logic class. So by doing the development using feature flag, what kind of benefits we enjoyed, I would like to touch upon, and they can be summarized into 4 points. And first, we can reduce the possible conflict. As I explained before, the development with feature flag, in that case, all the pull requests will be merged into a main branch in smaller pieces. So the each branch living period becomes shorter, so the change volume of the code also becomes small. So let's say another feature development is also ongoing in parallel. The sticker feature development and the theme feature development, these two are carried out in parallel. So in this diagram, the first and the last pull requests, the two requests, the two left and two right, if you focus on them, so there is no possibility to have conflict for these two pull requests. So you don't have to worry about that. So the conflict possibility could be focused on these two. So if there is a conflict, the pull request size itself is small, so the size of the conflict would be small. So the pull request itself is smaller. So in this particular case, in the middle, it is difficult to have conflict itself. So using a feature flag development style, is suitable for the environment. The many features are developed at the same time, so the conflict is less happened. So second point is the release schedule of the feature management. Management of the release schedule is much easier. So as I mentioned before, with the feature flag development, all the pull requests merged into the main, whether the feature is completed or not. So even though the feature is not completed, the merge is taken place. So in the middle of the feature development, there is a case that release branch is generated.
Due to the stamp feature, here we were planning to merge three pull requests, but after first pull request getting merged, version 1.0 release branch was created. So, using the feature flag for the development, the flag on the remote repository should be false like this. And then developer would make it as true when he build it. So by doing that, even though release branch will be created, this feature will not be executed on the release branch at all. And make the flag on the remote repository should be made true when the feature will be completed after the development. And then on the release branch, this feature will be enabled. So as you can see here, the final pull request will be matched, and then the feature flag should be changed to true. By doing so, the version 2.0 release branch, this feature will be enabled. And on the other hand, in the development of using the feature flag, if the release branch will be created, we cannot do the merge. Then we have to wait. So, using the feature flag for the development, we, developer, would have the feature release schedule and then development progress situation separately. We can see them separately. So even though the feature is complete, sometimes release might be postponed. So we can handle that situation. And then even if the development will be delayed and we have to change the release version, it will possible to change it, and then a branch management cost can also be reduced. That's a benefit. And thirdly, the enabling and disabling of the feature is relatively easy. So as I stated, using the feature flag for development, the bool value can be switched so that you can do the disabling and enabling of the feature. So in order to release this feature, let's assume that we do the QA on the release branch. So stamp feature version 1.0 release is planned. So version 1.0 release branch is doing the QA. So at this moment, the feature is planned to be released. So feature flag itself is true. So during the QA, unfortunately, something happened. Some bug was discovered, and it contains a critical problem. And then by the time we finish a QA or release the planned date, it will be difficult to fix. So version 1.0 release must be skipped. So in this kind of a situation, version 1.0 release branch, we have to make all the stamp feature related changes removed. So pull request should be reverted, and then all changes should be undone. So we have to make that change. But before cutting the version 1.0 release, pull requester would be if merged, that would conflict with the revert. That is disastrous. So only the proper portion needs to be reverted, but that would be difficult in this case. So by using the feature flag, even in this kind of a situation, you just make the feature flag as false so that you can disable the feature. So using the feature flag, you can minimize the impact to the other area or other portion, and then enable disable the feature quickly and simply. And finally, that would also beneficial to the collaboration with the other members. So by using the feature flag for development, on the main branch feature code can be visible during the development. And not just the developer, planner, designer, tester, all the other people can share the result of this. And then you can also use it for the demonstration presentation. And by making the feature flag as true, you can share that. And on the other hand, when it's a general user or partners, you can make the feature flag off so that you can block the exposure of the feature. So not just the engineer, for the other stakeholders, this development can be utilized by using the feature flag. So I've been talking about the what kind of benefits we can enjoy by using the feature flag for the development. I mentioned the 4 points, but there are some limitations in the feature flag used for development. So feature flag is not a silver bullet. When you do the update of the library API will get changed, and the feature flag development cannot have the compile. And in a prototype implementation, the change does not have to be merged to the branch of a main. So prototype branch would be good enough for the like a feature branch. So in our team, this February, our team, Mr. Ishikawa, made the session at the Droid Kaigi 2019. If you're interested in that, please refer to that one. And then feature flag using development system. How have our team has realized that? So in Line Android, at the end of the 2015, the script was introduced to create the feature flag value. This is a simple Gradle script file. And from the property file, we can tell when the flag would be enabled and the build type of application, whether it's a debug mode or release mode. Based upon this kind of information, the value would be generated. So it's possible to describe the property like this so that you can tell which build type will make this feature enable. And then we decide the value. And from Android Gradle plugin, you can write in the value from the script so that you can make a reference of that from the source code. So this simple script feature is expanding. It becomes more flexible, and then you can specify the feature flag value for your convenience. For example, PC user may has a certain name, and then make the feature flag as true, or application version is more beyond the certain version. You can also make the feature flag as true, and while triggering the application from the debug menu, you can switch the flag on and off, and then from the Gradle submodule, it is it is handling, so that we have more and more features, and the script itself are getting complicated. And then for the Gradle submodule, we had encountered several large problems until it can handle properly. What kind of a problems we had? But before touching that, I would like to explain how module is organized, structured, and how it is used in our project. So in the line Android, the left-hand side of the slide, app module is a parent, and then submodule are created, as you can see on the right-hand side of the slide. Submodule is from app module, grade implementation. There is an independency. There is a dependency of that. So app module, submodule becomes a dev beta RC release debug release according to the Android Gradle plugin. So they have the product flavors like this. So in order to create the feature flag, the script needs to generate the value. So I would like to go through that process.
アップモジュール内にフィーチャーフラグを生成するための
So
スクリプトが含まれています。
inside of the app module, there is a script to generate the feature flag, and this script is called from the build script, and also the property file with the feature flag information, and also the product flavor with which setting the build should be made. Such information is referred, and based on that, the build config class, the value is written, and before the multi-module, the feature flag required only by the main module, app module, and also the value should be generated by looking at the inside. But there are three issues since we used this script without knowing its implementation. So the first, the submodule responsible person actually copied the script to generate the feature. So from the submodule, it goes to the app property file, and so the reverse reference state is created. So in that way, the script was used. So originally, the submodule side don't have to refer the property file, which is the feature list of the entire app. And the second issue is so the product flavor used to decide the flag value, that is not the same. That is the different between the modules. So in app module, there is a feature flag in a property file, and that is described based on the app module product flavor. So if there is a property which don't exist in a submodule side, and the different value was generated. So this is another issue. And the third issue, so the build config class, the name is the same, but depending on the module, the namespace package name was different, so independent. So we didn't know the class was independent. So even though the runtime rewriting is performed from the debug menu, but that is reflected only one side. So unexpected behavior was generated at the time of the test. So I summarized the issues. So there are two major issues. So one is the different value from the expectation is generated. So due to the different product flavor, or the since the isolation of the build config class, so the rewriting of the during the runtime was not performed well. And the second major issue is the wrong dependency relationship between the module. So submodule side, the feature that it is controlling, or the flag inside of the feature which the submodule is depending on should be referred, but the parent side app module was referred. So with regard to the first issue, this is emergency issue. Also, the wrong feature flag value was generated on a app which was going to be released. So the wrong behavior may happen. So we had to fix it immediately. So we come up with a workaround to address this issue. So this is actual fix. So from the submodule flag reference is aggregated into the one module. So I would like to show you how the structure is changed. So this is the original. So with this state, as I described before, the feature flag value will be written into the different build config class on the submodule. So the destination of the feature flag value to be written make it the same. So the feature flag value generation logic is actually carried out by making the feature flag module. So we made that no value is created on the submodule. So the submodule, which is like a submodule sticker, is now depending on the feature flag module. Feature flag module refers the property file on the app module. Then the feature flag list is written. But this build config class is managed by Android Gradle plugin. So with this state is not sufficient. Still, it is a different class. And another reason to generate the different value is the build config is a different class of the different package. So still, there is a problem. So we decided not to use build config, and we prepare the feature flag dedicated class. And with that, the control is feasible by our side. So we can control from the script side with regard to the package name. So we can generate the completely same class. However, you might have noticed if you done the development with the Android or JVM language, there is a restriction. Only one class with the same package and the same name should be included in the class path of the app. So with this, there are two feature flag class. So we decided to use the compile only. So the compile only refer the class which is depending on at the time of the compile. So the class it is added to the class path, and when the actual execution of the code is carried out, this will not be included. So without including the actual binary, we could avoid this problem. When the app is executed, so there is no feature module, feature flag class. There is only one feature flag class in the app. So the feature flag class referred by submodule is the app module feature flag module. So with this, also from submodule, it can refer the right value of the app module. So the wrong value problem was solved. However, but this is the workaround. So the wrong value problem, the one problem was solved, but actually the more a problem occurred. So there are three new problem created by this workaround. So So the wrong dependency relationship, reverse reference issue was not solved. And also we have a very tricky implementation using compile only. On the IDE, the class is visible even though you use the compile only. So when you look at the feature flag class, so the different value from the expectation is visible. So also with compile only, that particular class is not used at the time of the execution, but this is the source of the confusion. And the third issue is this approach doesn't fit well with the unit test. So when you consider the submodule unit test, feature flag class itself does not exist. So it was more difficult to conduct the test. So it is not good to leave these three problems because it may become a technology debt. So we decided to add another fix to solve these issues. So the first fix is a workaround to address the issue right away. So we decided to solve that particular issue thoroughly. So it's okay to take time, but we decided to rewrite the system to generate the feature flag, and also within the module, the feature flag relevant process is completed, and we can separate the dependency correctly. So I would like to explain how we can make the dependency right.
So there is no major change of the app module, product flavor and the product file. We create the feature flag value and then write in the feature flag class. On the sub module, and same as app module, we have the same configuration. So submodule has a submodule own property file. If necessary, we add the product flavor. And the feature flag, where we write in the feature flag value, we give it the separate package name. So same package name compile only would be rewritten. That would not happen. We handle it as a completely different class. But not just that would solve the problem of the integration between the module. From the parent module to the child module, we make the link possible. So link can be described on the property file, and you can describe which module, which flag should be referred. On the code, simply it is referring to the different class field. So let's take a look at how these values are created. So link is expressed which submodule which is flag should be there. So in this property, the feature stick flag, submodule stick flag, the feature stick player flag would have the link in this case. So property, how to write the property, I would skip it in detail. But as a format of the property, they are connected with the and then comma it will be expressed as or. Ampersand is and. So it is described like this. So now, until we we determine the flag's value, we have to interpret the dev or release phase. So under which conditions we can enable the fetch. So it is described from the build script, but now you can design it freely. But here, if it's a build variant is a debug, it's a dev phase. Build variant is release, it's going to be the release phase. Let's think like that. So let's look at the debug variant case. So in order to determine the feature flag value, we have to go through two steps. So first, based upon the builder variant information, we should determine whether the phase is enable or disable. So this time, debug variant case, only the dev phase would become true. So dev would be true and release would be false. And on the hand, submodule, sticker module, the feature sticker, player flag, link, phase interpretation, which should not be considered. So it will be carried over as it is. So we're going to delete the element that can be omitted. So it makes it the most simple step. So to the true, we have the or. So the element as a whole, whatever the value would be true. So by doing so, in the debug variant, the feature script flag would become true according to our computation. And then we thought about the release variant case. So earlier is the same as a debug variant. We go through the steps. There are three steps here. The first two steps are the same as I have just mentioned. So in case of a release variant, release phase only would become true. So dev would false, release would be true. And in the optimization step, it's not going to be true or false. And the submodule, sticker module, feature sticker player flag link element only would be remaining. So this element would be finally implemented because we are going to refer the actual submodule feature flag class. So even though it's a link, it looks like the code is generated as we make the reference on the program. So finally, release variant would have the flag submodule sticker module feature sticker player flag. So the element would be referred on the code. So submodule flag would become a certain value, but on this module you don't have to be aware of that, so that the integration between the modules would be easier. So our line under the team is using the feature flag for our development and generate the flag, how we have improved the script to generate the flag value. So there are 3 points for improvement. So first one, we could resolve the improper dependency relationship, no reverse reference, and then a correct dependent relationship is now created. And secondly, submodule can have the correct value of its own. By doing this, submodule itself can be shared with the other applications, and then it would not look at the application specific flag. And then third point, when we do the re-implementation, it used to be the grade script, but now it's a grade plugin. So for the other project, you can apply this simply. So line Android specific behavior has been removed so that it's more portable with the other project. So plugin is going to be published from today as an OSS so that anybody can use it. So the setting for value creation can be done from the builder script. So buildable variant and which phase can be configured for each project. So in the plugin, it's published on the GitHub, so we have the Android project, but you can easily introduce it. And the Glade plugin portal So we are applying for that. If it's approved, it will be used. So this is the end of the session, but finally I would like to recap 2 points. By using the feature flag, we can avoid a conflict hell or complicated revert, as we saw with the feature branch utilization development. And then on the Android application, by using the feature flag, we have the Gradle plugin. Now it's been published. So if you are interested in, please go ahead and use it. Thank you very much.